sheet 1. What is the first thing we want to do with everything if we can? Sine and cosine. So secant, I know, equals 1 over cosine x. That's a reciprocal. Tangent is sine over cosine x. Cotangent is cosine x over sine x. Okay, do you want me to show you a fast way to do complex fractions? Because most of you, what I would expect you guys to do is get common denominators on the bottom and then add like terms, because there's two fractions down there. But there's a faster way to do them. Do you want me to show you? Okay, here's the faster way to do them. The faster way to do them is look at your denominators, all the denominators, and ask yourself, what's the common multiple of those numbers? Which means least common denominator of all those things. Cosine, sine, and cosine. What do you do to figure out the least common denominator or the common multiple, least common multiple? Anybody know? Anybody tell me how to do that? Okay, let's say I had numbers like this. Let's say I had 1/2 plus 1/3 plus 1/5. How would you find the common denominator? You know, better yet, I'm going to put 1/4 over here because it's more like that. What do you do to find a common multiple? Do you know? Somebody's got to know. You've been doing this since 5th grade. I know you have because my son's in 5th grade and I help him with his math almost every day. What do you do? Okay, you could multiply them all together and get a common denominator, but it may not be the least. And here's why. 4 breaks down to 2 times 2, doesn't it? Right? So what you're first supposed to do to find your least common denominator is, do you have anything in common? Well, I got a 2 here and a 2 there, so that means I can just do one of those 2's. And now these are done. I don't have to worry about those anymore. And now nothing else is the same, so I got to multiply them all together. So the least common denominator here is 12. Now, do you see if I multiply them all together, I got 24? 24 is a common denominator, but not the least. Okay? So going on that pattern, I look over here. Look, I got a cosine and a cosine. So that's part of it. That's part of it. And then what's left over is that sine, so it's cosine times sine. There's my LCD right there. You see how I did it the same way with the numbers, but with the trig functions? So I multiply the top by the common denominator, and I multiply the bottom by the common denominator. Okay? So then I'm going to take this over here times this. Now this is just faster than the other way. I hope you see that this cosine will reduce with that cosine. Do you see it? When you multiply? So what am I left with on top? Sine. I've got sine on top. Okay, then I'm going to take these 2 over here times this one. When I take these 2 times this one, I'm going to put them over here beside this. Does anything reduce? Anything reduce, top, bottom? Can't really see that one. I'm going to put it over here. Anything reduce on this? The cosine. That cosine and that cosine will reduce. What am I left with? Sine times sine. What's sine times sine? Then you got this plus sign, so I'm going to put a plus sign right there. Then I'm going to take this sine cosine times this cosine over sine. Does anything reduce with these and this? The sine and that sine reduce to 1. Oh, it's cos times cos. Now we just had this a second ago. What's this bottom part equal? 1. So I can put in 1. And what's anything divided by 1? That's itself. You see how multiplying through by that LCD made it simpler? Are we thumbs up with how I do that? Then that's kind of hard.
I still understand how you did that.
how I did the LCD. Okay, do you see how I did it over here? I broke them down and I found what was in common first. These, there was a 2 in those two, so I get to write a 2 down. And then there was nothing else in common. I had an extra 2 and an extra 3. So whatever is not in common, you also have to write down. And then you multiply those together where your LCD comes from. So going back to this problem, let me start over here. I got 1 over cosine x over sine over cosine x plus cosine x over sine x. So I'm looking at the denominators. I'm looking at this and this and this. Do I need to write those numbers back down over here? Okay, so if you remember, I had this, right? What did I do first? I looked for what first? Is there anything common in the bottoms? And my answer was over here, yes. There's a 2 and a 2, so I write down a 2. So my question is, over here, is there anything in the highlighted denominators in common? Cosine. So I write it down. So I have taken care of the cosine. Now, what did I do next? I didn't find anything else in common, so I had to multiply that by everything else, right? Do I have anything left over not in common? Sine it. So that's the rest of it. So right there's your LCD. Same way I did with the numbers, but with the trig functions. Do we follow? Are we thumbs up on that? And then you take whatever this common denominator is, and you multiply every single part by it. So I'm going to take this top part and multiply it by sine x cosine x. And you're going to put it over 1 because this is a fraction. And you're going to multiply this one by sine x over times cosine x, and you're going to put it over 1. And you're going to take this one over here, and you're going to take this times sine x cosine x, and you're going to put it over 1. You multiply every single part by it, and then you reduce. So that and that go away. They go to 1s. So I have sine on the top. This cosine will reduce with that cosine, so I have sine times sine. So on the bottom I have sine squared x. Then I got that plus sign, so I need to put it. Then I look. This reduces with that. So I got cos times cos, so this is cosine squared. You see how it works? So then I'm left with sine, and if you know your Pythagorean identities, that's a 1. You can put 1 in for this. And then this whole thing is just sine. Okay? You get it? On your thumbs up. It's kind of a big deal. You can do this algebra stuff. This stuff is really algebra type stuff. All right, I'm going to go to the next one. So this next one, get out of the way, please. Pretty please. Thank you. All right, there's not really a shortcut on this one either, so I'm going to change everything. I'm going to change everything into sine and cosine, just like I asked you to do. Now I'm making these fractions because that middle one's a fraction. Question so far? Okay, now I would probably do this one a little bit differently. You don't have to, but I probably would. You see, the reason this one is different is, do you see there were 2 different things down here I was adding? Y'all see that? That's why I did that one the way it is. This one's only got 1 fraction in the bottom. So if you're thinking about the old days of just numbers, what did you do when you had a fraction divided by a fraction? What do you do with that thing over there on the right? What? No. You take the bottom one, you flip it over, and multiply by the reciprocal. You remember doing that? That's why if you remember the old days, it makes this stuff easier. So this 5 will reduce with that 10 to a 2, so this whole thing would just be a 6. You see it? You see I have 1 fraction here? So what I'm going to do is I'm going to multiply this top part by the reciprocal of this. I'm going to write it on this side, cosine x over sine x. I'm going to flip it over just like I did on the other one. I get that. You see it? I took my fraction that was on the bottom and I flipped it over and multiplied the top by the reciprocal of tangent. I had a sine x over a cosine x, right? Just like I had a 1 over 10. So I flip the 1 over 10 over, and I'm multiplying it by the top. Maybe I should all right, I'm going to rewrite it. I was trying to do it there because I don't have much room. So I got the top part just like that 3/5. I'll leave 3/5 alone. So I'm going to come down here and rewrite the top part. I got cosine x over 1 times sine. Oh, you know what? I could already simplify something right here. What can I do right here? Yeah, then this cosine go away. You see they already reduced? Okay. So let's see, down here I got sine x over cosine x. So I probably should have done this already. So I'm going to cheat and go back up there and do this again. So if those reduce, they're gone. They're ones, so they don't do anything. So now I have this. Y'all see it? So now I'm going to take this bottom one, and what am I going to do with this bottom fraction? What do I do with that bottom fraction? Flip it over and multiply by it. So can I just flip it over and put it right here beside this? And then erase it down there. What I'm actually doing is I'm actually doing the top and the bottom by that reciprocal is what you're actually doing. So these all reduce down to 1 in the bottom. Do you see how it goes away now? Yes, Harvey.
When you do the reciprocal on the top, do you have to do it on both sides or both?
You do. It's a distributive property. Yeah. You're going to take this times everything.
Right.
So what you can do is you can write it here by this one, and then you can come over here and write it by this one if you wish. Now I could have also added these now because they're like terms, aren't they? You see how they're like terms? So I could have gone ahead and added them. That would have been simpler. But anyway, do you all see this sign and that sign reduced? So what am I left with there? And I just cosine x left with a plus sign, and then this sign and that sign reduced. So I'm left with a cosine over there. If you have one cosine and you add another cosine, how many do you get? So this answer is 2 cosine x's. Now again, I want to show you that I could have gone ahead and taken these two because they're like sine x plus sine x. You could have done 2 sine x over 1. And then if you take this cosine x over here times sine x, flip it to multiply, that and that reduce, so it's 2 times cosine, it's still 2 cosine. How do you get from here to downtown Indianapolis, down to the circle center? How do you go? Huh? Is there only one way to get there? No, you can go over and hit 65 and go downtown and get off on Market Street. Or you could go down to Wanamaker and get on 74 and go up to 70 and take 70 downtown. Right? You could even take all that. We could hit Southeastern Avenue and take it all the way down and go to Washington Street and hang a left and go over and go to downtown, right? Right? You can these things, you can do that too. There's many ways to go to where you want to go. Okay, you can get there as long as you use math rules that are real and identities that are true. You can get to the end. All right, I'm going to keep going here. I'm talking too much. So here we're going to do this again. So I get cosine x. I'm going to make that a fraction because I see I got a fraction coming over here. This is sine x over 1, and then this is sine x over cosine x. Am I going too fast? So I'm going to multiply these two together. Does anybody know what sine x times sine x is? That's sine x squared. That is correct. Now, how do I add? What are you supposed to do? What are you supposed to do to add fractions? Anybody know? How do you add fractions? How do I take 4 over 1 plus 2 over 3? What do I do? Common denominator. Now we just did common denominators, 1 and 3. Anything alike? So you multiply them together. 1 times 3. My common denominator is 3. So you would multiply this by 3 over 3 and get 12 over 3 plus 2 over 3, and we get 14 over 3. Y'all remember that? Same story here. We got a 1 and a cosine. I got to get them the same. What's my LCD? Cosine, because there's nothing alike. 1 times cosine is cosine, so I got to multiply this side by cosine over cosine to get a cosine in the bottom. What's cos times cos? Can't hear you. Cosine times cosine? What's cos times 1? Cosine. Do you see we've got the common denominator now? I'll put this over cosine. Now, what's that top part equal? We've already done this one. 1. Cosine squared plus sine squared is 1. So So this is 1 over cosine squared, and you're not allowed to leave a fraction. So which one of the identities will it be since there's a 1 on top? It's going to be a reciprocal. This thing equals secant, and I'm done. Question? Is this helping? Okay. Then go to the next one. Now everything's in terms of numbers, sine, and cosine, so I'm not changing anything here. What do you think you should do first on this problem? I put down change things to sine and cosine first, right? Then it's already there, so what's the next thing to do? Do math rules. Can I do anything to the top part? Is that top part telling me to do anything? I think it is. I see a parenthesis and by a parenthesis right here. I see a parenthesis by a parenthesis. What does that mean? Multiply. That means multiply. So I've got to do double distributive or FOIL. Do you see there's 2 terms in the first one, 2 in the last one? FOIL. I'm going to do it the long way first, and I'm going to tell you why you should have, there's a shortcut. So I'm going to take this 1 times both of those things. So I get 1 times 1 is 1. 1 times negative sine is negative sine. Then I'm going to take this sine times both those. Sine times 1 is sine. And sine times negative sine is negative sine squared x. And then I got all that over cosine x. Remember how to do FOIL? Yes? Do we have any like terms on the numerator that we can put together? Negative sine x plus sine x. What's a negative sine and a positive sine do to each other? They cancel out. They go away. There's 0. This and this are 0. So I've got 1 minus sine squared x all over cosine x. Look at that numerator. What do you notice? You got 2 things, and one of them's got a what? One of them's got a what? Power. A square. What should pop in your brain? 2 things with 1 squared. Pythagorean identities. Look on your first column. Did 1 minus sine squared equal something? What's it equal? So I'm going to put cosine squared in for that. Now, if I have x squared over x, what are you allowed to do? Doesn't x squared mean x times x over x? Can't you take one of them and reduce it and get x? Or subtract the exponents is the shortcut. 2 minus 1 leaves 1. Same story here. 2 minus 1, 2 on the top minus 1 on the bottom, leaves cosine. Done. Now I'm going to show you the faster way to do this because we've talked about this before. We said when there was 1 minus and 1 plus, those are called conjugates. Do you remember the word conjugate? And I told you that you always get a difference of 2 squares when you FOIL them. So if you square the first minus square the last, you're done. These are conjugates. So if you remember conjugates give you the square of the first minus the square of the last, we could have taken a whole step out and been there 1 step earlier. You see what I'm saying? So if you recognize stuff that you've had in the past, it makes these easier. All right, now this one you might think, hey, we FOILed the top part. We FOILed the top part and it helped us out. If we FOIL this one, it's not going to help because look at this first term here. What do you notice about a power? What do you notice about? It's got a second power and there's 2 things. A second power and there's 2 things. What? Look at your Pythagorean theorems. Look at them. Does 1 minus cosine squared equal anything? So I'm going to stick sine squared into there. Does 1 plus cotangent squared equal anything? Cosecant squared. You see it? Now, look at your multiplication identities at the very bottom. What's sine times cosine? Or sorry, sine times cosecant. 1. So if you got 2 here and 2 there, they're both 1s. Now, if you don't remember that, you can use the reciprocal identity and make this 1 over sine squared. And then that'll reduce with that, but it gets to that same 1. If you remember sine squared times cosecant, they're reciprocals. They cancel each other out, just like they did here when I changed them to sine squared. They're 1. You understand? Are we thumbs up on this or not? All right, we got 1 more to do. So this one doesn't look like it's got, this, remember doing this one? This one is almost identical to it, except they changed the cotangent over to here. So this is cosine x times cosine x over sine x plus sine x over 1. So can you guys tell me, what is cosine over 1 times cosine over sine? What is that? Anybody? All right, let's do this first. What's your LCD? What's your least common denominator? Sine. 1's in common, 1 times sine, sine. We need a sine over here, so we multiply this side by sine over sine. Because we got to get a sine on this one and a sine on this one. What's cos times cos? Yeah, what's x times x? X squared, isn't it? Cos times cos is cosine squared. Okay, plus, I'm going to just go ahead and put my common denominator sine down here because I got one on each side now. What's sine times sine? Sine squared. What's that numerator thing equal again? I got two things squared. 1. 1 over sine, the reciprocal of what sine is. And I'm done. You see how that was very similar to that one? Okay, I'm going to shut off the video so it's not too long because it's